4.5 billion years ago, the solar system as we know it did not exist. There was no sun as we see it today, no planets circling in graceful orbits, no moons, no oceans, only a vast, cold cloud of dust and gas drifting through the galaxy. This was the solar nebula, the ashes of older stars, waiting to be gathered into something new. Gravity, the invisible hand of creation, began to take hold. Slowly at first, then with increasing force, the nebula collapsed inward, spinning faster as it shrank. At its center, pressure and heat ignited, and a star was born. Our sun. Around this fiery newborn, the leftover matter flattened into a swirling disk. Within that disk, countless grains of dust collided and clumped together. Tiny particles became pebbles. Pebbles became rocks. Rocks became mountain-sized bodies. It was a violent nursery where collisions were as common as creation. But from that chaos, order began to emerge. These growing bodies, called planetesimals, slammed together with enough energy to melt rock and metal. Each impact fused them into larger and larger worlds. Among the emerging planets were two that seemed destined to be alike. Earth and Venus grew side by side in the inner solar system. Both were forged from the same cosmic ingredients, silicate rocks, metals like iron and nickel, and volatile compounds that would one day form atmospheres. Venus, only slightly smaller than Earth, shared nearly the same mass and density. Its iron-rich core, rocky mantle, and crust were sculpted by the same processes that shaped our own world. In many ways, they were twins. Their diameters differed by less than a few hundred kilometers. Their gravitational pulls were nearly identical. To an outside observer, looking at the solar system in its infancy, Earth and Venus would have seemed like siblings born from the same fire. If Earth had the potential for oceans, continents, and life, then surely Venus did too. The young Venus likely looked strikingly familiar to what Earth was becoming. Its surface, battered by impacts, was partly molten, cooling into a crust that shifted and cracked. Asteroids and comets bombarded both worlds, delivering water and other volatile compounds. Venus may have received enough water to form shallow oceans or vast lakes, its surface steaming under the warmth of a still dimmer sun. For a brief time, the two planets may have been nearly indistinguishable, both capable of nurturing habitable conditions. Beneath its surface, Venus's story mirrored Earth's even more closely. Convection in its mantle drove volcanic activity, reshaping its crust. Its dense core held the heat of formation, and its gravitational pull anchored an atmosphere rich with carbon dioxide, nitrogen, and perhaps traces of water vapor. By every measure, Venus stood as Earth's sibling, not just in size and mass, but in potential. And yet, even in these early days, subtle differences were already setting them apart. Venus orbits closer to the Sun, about 30% nearer than Earth. That small distance meant slightly higher temperatures, a slightly stronger solar influence, and a delicate balance tipping in a different direction. Where Earth began to cool just enough for water to condense into oceans, Venus remained warmer, its water more likely to linger in the atmosphere as vapor. At this stage, the divergence was invisible to the eye. Both planets were young, volatile, and full of promise. Both carried the raw ingredients for life as we understand it. But hidden within those small differences lay the seeds of two profoundly different destinies. The birth of Venus, then, is not just the story of another planet forming from dust and fire. It is the story of a mirror world, a near twin to Earth, born under the same star and from the same materials. Its resemblance to Earth was uncanny, almost eerie, as though the cosmos had decided to craft a double. But the universe rarely repeats itself exactly. Even the smallest variations in orbit, temperature, and chemistry can shift the course of billions of years. Venus began its life as Earth's twin, sculpted by the same cosmic forces, nurtured by the same sun. For a time, its fate seemed bound to ours. And yet, as we will see, this twinship was fragile. The same beginning would not guarantee the same future. While Earth would grow into a cradle for oceans, forests, and life, Venus was already drifting toward a destiny that would make it one of the most hostile worlds in the solar system. The story of Venus's birth is both familiar and foreboding. It shows us how planets are forged, how similarities can mask differences, and how fate can hinge on the smallest details. In the beginning, Venus was Earth's sibling in every way that mattered, but the path from birth to present is long, and for Venus, that path would twist toward extremes no one could have imagined. When Venus first settled after its violent birth, it may not have been the furnace we know today. In fact, some models suggest that for hundreds of millions of years, perhaps even longer, Venus could have been surprisingly gentle. Its surface may have been marked not by blistering heat but by shallow oceans. Vast stretches of water, perhaps no deeper than a few hundred meters, could have covered its lowlands, while its higher ground might have stood as continents. If so, early Venus might have been a world of blue skies and rolling clouds, a planet not unlike the young Earth. The sun, too, played a role in this delicate balance. Billions of years ago, our star was dimmer than it is today. Its light was weaker, its heat less intense, which meant that Venus, though closer to the sun, received less energy than it does now. This subtle difference may have delayed the onset of the runaway greenhouse effect that would one day seal its fate. Instead, the planet may have rested in a narrow window of time when its climate was mild, its atmosphere more forgiving, and its surface cool enough to allow liquid water to persist. Imagine for a moment what such a Venus might have looked like. Shimmering seas reflecting a softer sun, rainfall feeding rivers that carved through volcanic rock, clouds drifting across a sky tinged by volcanic dust, but not yet suffocating in sulfur and carbon dioxide. It is not impossible to picture a Venus that felt familiar, a world that, if viewed from space, might have seemed almost indistinguishable from Earth. This is why planetary scientists often speak of Venus not simply as Earth's twin in birth, but also as a potential twin in habitability. For a time, it may have had the right conditions, the right temperatures, and the right chemistry to sustain a stable climate. In fact, computer simulations suggest that Venus could have remained temperate for as long as 2 billion years, long enough for oceans to form, weather patterns to stabilize, and perhaps even the earliest forms of habitability to take root. But within this apparent paradise lay a precarious balance. Venus was always closer to the sun, and even with the star's dimmer light, it absorbed more heat than Earth. Its atmosphere, rich in carbon dioxide, trapped that heat more efficiently. Its water, present mostly as vapor in the air, magnified the greenhouse effect further. Each of these factors meant that Venus was always walking a tightrope, teetering between habitability and catastrophe. Scientists describe this moment in Venus's history as a fork in the road. Had conditions remained stable, had Venus found a way to cool itself, perhaps through oceans that absorbed carbon dioxide or geological processes that locked greenhouse gases into rock, it might have stayed Earth-like. With just a little luck, Venus could have developed a climate that balanced heat and cooling, water and rock, atmosphere and ocean, just as Earth eventually did. Two planets side by side, both nurturing oceans, both capable of fostering life. But Venus chose, or rather, was forced into a different path. The very factors that once gave it promise also carried the seeds of its downfall. Its oceans, if they existed, were shallow compared to Earth's and more vulnerable to evaporation. Its atmosphere lacked the balance needed to regulate carbon dioxide over the long term. And, as the sun grew brighter with age, Venus absorbed more and more heat, tipping the scales against stability. At the fork in the road, Earth turned toward life, Venus turned toward ruin. And yet, reflecting on this ancient possibility changes how we see the planet today. It reminds us that Venus was not always the blazing inferno we picture. There may have been a time when it was calm, temperate, and even beautiful. A world that could have shared an Earth story, that could have been habitable, that might have been a second oasis in the solar system. The early Venus stands as a haunting reminder of how fragile planetary balance can be. A shift in orbit, a change in atmosphere, a sun that brightens with time, each factor nudges a world in one direction or another. For Venus, those nudges carried it down a path of escalating heat and suffocation. But in its earliest days, before the catastrophe, it may well have been Earth's true twin. The early Venus may have walked a delicate line between habitability and disaster, but that balance could not last forever. As the planet aged, the forces shaping its destiny began to tilt sharply in one direction. The first signs of catastrophe came from deep within. Venus was, and still is, a volcanically active world. For hundreds of millions of years, eruptions raged across its surface, releasing vast quantities of gas into the atmosphere. Carbon dioxide, in particular, poured out from countless volcanic vents, blanketing the planet in a thickening shroud. Each eruption added more fuel to a growing greenhouse effect, trapping heat that could no longer escape into space. On Earth, oceans act as a thermostat, absorbing carbon dioxide and storing it in rock. But Venus had no such stabilizer. Its water was shallow, its ability to regulate gases limited. The carbon dioxide built up relentlessly, layer upon layer, until the atmosphere itself became suffocating. At the same time, the sun was slowly changing. Like all stars, it grew brighter as it aged, sending more energy outward into the solar system. Venus, already close to the sun, bore the full brunt of this intensifying heat. What might have been oceans or shallow seas began to evaporate more rapidly. Water vapor rose into the skies, joining carbon dioxide in thickening the greenhouse blanket. Water vapor is one of the most potent greenhouse gases, and on Venus, it created a vicious cycle. The hotter the planet became, the more water evaporated. The more vapor filled the sky, the more heat was trapped. Temperature spiraled upward, accelerating a process scientists call a runaway greenhouse effect. Venus had crossed the point of no return, but the catastrophe did not stop there. The sun's ultraviolet radiation struck the water vapor high in the atmosphere, splitting the molecules apart. Hydrogen, the lightest element, escaped into space, carried away by the solar wind. Oxygen, left behind, reacted with surface rocks or combined into other compounds. Slowly but inexorably, Venus lost its water. What may have once been shallow oceans or vast lakes simply vanished, broken apart, and bled away into space. Without water, Venus lost its last chance to cool itself. On Earth, water shapes the climate, regulates heat, and fuels the cycles of carbon and life. On Venus, the disappearance of water meant there would be no moderation, no balance, no return to gentleness. The greenhouse effect tightened its grip, locking in the heat, driving surface temperatures higher and higher. Imagine the transformation. A planet that may once have been temperate now sweltered under a sky of suffocating gas. Clouds thick with carbon dioxide and sulfur dioxide wrapped the planet like a heavy blanket. Rain, if it fell at all, was acid, not water. The surface baked until it glowed, turning into a barren wasteland. What had once been the twin of Earth was becoming unrecognizable. The runaway greenhouse effect was more than just a climate shift. It was a planetary-scale catastrophe, a tipping point from which there was no return. Oceans boiled away. The atmosphere thickened into a crushing wall of gas. Temperatures climbed until the surface could melt metal. Venus had entered a new phase of its existence, sealed by the very chemistry of its skies. This catastrophe defines Venus even today. It was not a sudden event, not an instant collapse, but a long, inevitable process driven by the interplay of volcanism, solar energy, and fragile balance. Each factor fed into the next, each change amplified by the one before it. Together, they transformed a world that might have been habitable into a world that is now a furnace. The runaway greenhouse is the great dividing line in the story of Venus. It is the moment when Earth's twin became Earth's warning. One planet stabilized, balanced by oceans and cycles that allowed life to flourish. The other spiraled into suffocating heat, stripped of water, sealed beneath clouds of acid and carbon dioxide. In those billions of years, the fate of the two siblings split apart forever. The catastrophe of Venus is not just a planetary tragedy. It is a reminder of how thin the line between habitability and hell can be. A few million kilometers closer to the sun, a slightly different balance of gases, a fragile atmosphere pushed just beyond stability, and the outcome is irreversible. Venus's story is not only about what it became, but about how quickly a promising world can unravel when conditions slip out of balance. Today, Venus stands as one of the most hostile environments in the solar system, a place where conditions defy imagination. Its surface temperature averages around 465 degrees Celsius, hot enough to melt lead, zinc, or tin with ease. Day or night, pole or equator, the furnace never cools. Unlike Earth, where weather and seasons create change, Venus is locked in an eternal, suffocating heat. To stand there, even for an instant, would be to step into an oven that never turns off. The atmosphere is the architect of this inferno. Composed of 96% carbon dioxide, it is a greenhouse gone mad. The thick air traps nearly every ray of sunlight, recycling it endlessly, refusing to let the heat escape. Above the surface, the pressure is 92 times greater than Earth's, the crushing equivalent of being a kilometer beneath the ocean. Any human, or any machine not specially reinforced, would be flattened instantly. But the atmosphere holds more than just pressure and heat. Suspended within its upper layers are clouds of concentrated sulfuric acid. These corrosive veils stretch for kilometers, hiding the surface from view and reflecting sunlight back into space. From a distance, they give Venus its dazzling brightness in our night sky. Up close, they are a toxic shroud, capable of destroying metals and machinery. Within these clouds, lightning rages bolts far more frequent than those on Earth, arcing through the dense atmosphere with explosive force. And the winds themselves are extraordinary. High above the surface, the atmosphere moves in a phenomenon called superrotation, while the planet itself spins slowly, taking 243 Earth days to complete one rotation. Its atmosphere races around the globe in just 4. This hurricane-like circulation whips the skies at hundreds of kilometers per hour, dragging the sulfuric acid clouds with it, creating a ceaseless storm that engulfs the planet. The contrast is staggering, an atmosphere moving with ferocious speed while the surface beneath crawls through its glacially slow day. The surface, when glimpsed by radar and the few landers that survived there briefly, is a wasteland of volcanic plains, towering mountains, and fractured highlands. Vast lava fields stretch across much of the planet, evidence of its violent geological past. Enormous volcanoes, some larger than anything on Earth, stand silent, though many may still be active beneath the crushing atmosphere. The rocks are scorched, baked, and weathered not by water but by acid and heat. No river flows here, no ocean glistens, no wind carves valleys of comfort, only desolation shaped by fire and suffocation. For spacecraft, Venus is nearly as unforgiving as for humans. The Soviet Venera landers of the 1972nd and 1982nd managed to touch down, sending back haunting images of cracked ground and barren horizons. But even the most rugged designs lasted no more than 2 hours before the pressure crushed them and the heat silenced their instruments. In a world where metals soften and electronics fail, survival is measured in minutes, not days. Yet, despite its hostility, Venus is mesmerizing. From Earth, it shines as the brightest planet in the sky, often mistaken for a star at dusk or dawn. To the naked eye, it appears calm, serene, and beautiful. But beneath that brilliance lies the reality of a world turned against itself, a place where everything familiar about Earth has been twisted into extremes. Venus today is a reminder of the power of planetary atmospheres. A small difference in distance from the sun, a lack of water to balance its gases, a history of volcanic outgassing, and the result is a planet that became a prison of its own atmosphere. It is, in every sense, a hell planet, a cautionary tale written into the fabric of our solar system. Standing at this point in the story, we can look back and see the twin ship with Earth broken forever. Venus, once a world of potential, is now an alien landscape, hostile to life as we know it. Its heat, its pressure, its toxic skies, and its endless storms all combine into an environment that humbles even our most advanced machines. Planet that once promised familiarity now offers only warning. Venus is more than just a planetary curiosity. It is a warning, a living example of what can happen when a planet's delicate balance tips too far. On Earth, greenhouse gases warm our world, keeping it habitable. But on Venus, the greenhouse effect ran unchecked, transforming a once Earth-like planet into an unrecognizable inferno. Its story is a stark reminder that planetary climates are fragile and that small changes can spiral into catastrophic consequences. When we study Venus, we are, in many ways, looking into a mirror that shows not what we are, but what we could become if we fail to manage our own atmosphere. Venus also broadens our vision beyond Earth. In the search for exoplanets, worlds orbiting distant stars, the question is often whether we are finding another Earth or another Venus. Two planets can begin in similar conditions, with similar sizes, masses, and orbits, yet end with radically different fates. Understanding Venus helps astronomers interpret alien worlds, distinguishing between those that might harbor oceans and life, and those that are trapped in suffocating, unlivable conditions. Every Venus-like world we discover deepens our understanding of the knife's edge upon which habitability rests. This is why the upcoming missions to Venus matter so profoundly. NASA's Da Vinci Plus mission will plunge through the planet's thick atmosphere, sampling its layers, measuring its composition, and searching for clues about its lost oceans. Veritas, with its advanced radar, will map the surface in unprecedented detail, revealing whether Venus is still geologically active and perhaps exposing evidence of past water flows or hidden volcanoes. Together, these missions promise to rewrite our understanding of how Venus evolved, and by extension, how planetary environments everywhere evolve. Europe and other space agencies also have their eyes on Venus, recognizing that its secrets are key to unraveling the mysteries of planetary climate, geology, and atmosphere. Each probe and each dataset builds a clearer picture of how a world that began like Earth became so profoundly different. These efforts are not just about Venus itself, they are about us, about our future, and about the countless worlds that dot our galaxy. When we reflect on Venus, we confront both awe and humility. Awe because it is a planet of extremes, a natural laboratory of climate and geology operating at their most intense. Humility because it shows how quickly and irreversibly a world can be reshaped. It forces us to recognize that Earth's stability is not guaranteed, that maintaining balance requires vigilance and understanding. Venus, in the end, is not just a planet of fire and acid. It teaches us about the boundaries of habitability, about the forces that can undo oceans and erase possibilities. It teaches us how to read the signs of life or the absence of it on planets light years away. And perhaps most importantly, it teaches us responsibility to safeguard the balance of our own world while we still can. This is why Venus matters. Its inferno is not only its story, it is our warning and our opportunity to learn. If we listen carefully, the lessons written into the skies of Venus may help us protect the only true twin that remains, Earth itself.